But a couple other things that are more like logistics based around the course. So tonight, like I was saying, this will be about an hour. We have 3 presenters. Myself and Alex and Ella are here. And for the field days, scrolled too quickly. For the field days, we have snowmobile field days this weekend at Buck. And if you are unsure of what day you're signed up for, go ahead and send that friendsofgnfac@gmail.com an email, and we can get you squared away. The ski and snowboard days at Bridger are coming up in a couple weeks. So that'll be the weekend after this one, MLK weekend, and the weekend of the 21st and 22nd. So any of those like logistical questions, the Friends of GNFAC email box is a really good way to get those questions answered. But really important things for these field days are just like where you're meeting, what you're bringing with you. So for the snowmobile course this weekend, you'll be meeting in the Buck Ridge parking lot just south of the corral. Plan to be like, you know, ready to go, ready to ride at 9 a.m. And a really important thing, especially for this weekend's field day, and really all of them, is to make sure you sign your waiver ahead of time, especially up at Buck Ridge, because you're not in cell service. At the trailhead, it's a lot more difficult to deal with waivers and emergency contact info and stuff. But even for those ski days, just make sure you're signing that waiver ahead of time. That's like how we track your emergency contact information should anything happen to you out there. But yeah, the Bridger meeting location is going to be at the Jim Bridger Lodge deck. So this is kind of just adjacent to the Sunnyside chairlift at the base of the ski hill. And if you have any questions about where that is, yeah, shoot that friendsofgnfac@gmail.com an email, and we can line you up. Other than that, like as far as what you're bringing to the field day, like just be prepared to be outside for 6 hours, regardless of the weather. So bring everything you'd normally bring to go out snowmobiling or skiing. Just make sure you've got enough stuff to stay warm, because we won't be inside at any point during these field sessions. If you have any questions about what to be bringing, refer to those kind of logistics emails from Eventbrite and from the Friends Gmail, or just ask us a question if you don't know what to bring. Cool. So any questions so far on like what tonight's going to look like, or any big picture logistics so far? I just open the floor if anyone has any questions about these field days. I don't see anything pop up in the chat or Q&A so far. Oh, here we go. Snowboard leashes. I'm going to just answer this question live. If you normally ride at Bridger and they require you to have leashes to ride the lift, you have to bring leashes. I know for people who have bindings without brakes, they want us to be wearing leashes. So thanks. Okay. My screen just jumped ahead a couple slides. But what we're gonna dive into, I just got a question in the chat. I think we'll clarify location. So it looks like Sam in the chat, like you have the right location. It's the Buck Ridge parking lot just south of the corral. That's the location. If anyone who's in the sled course like needs more specifics on location, I can just send out a pin on a map through Eventbrite later too. But thanks for those questions. That's why we want you to tune in, so you can get your questions answered before you show up. But yeah, just to kind of dive in, transition from the logistics into what I'll be talking about. I'm just giving a kind of brief overview recap and the terrain recap. And then Alex will talk about snowpack and weather. I will talk about human factor and decision making, and then Ella will talk a bit about avalanche rescue. And so with each of those kind of subcategories, we'll be stopping and like answering questions if you want to raise a hand or put them in the Q&A. So it won't be kind of like ongoing question answering. It'll just be intermittent, like after the recap slides are done, then we'll answer those questions. If that sounds good. So a couple things that I will be covering in this first up recap is just a introduction to why we care about avalanches, review of terminology, and then identification of avalanche terrain and consequence. And then a couple simple steps to keep yourself safer, because like we always want to bring back what we talk about in these lectures or in the field sessions to like how do you apply this to yourself out there. So the most important element of this talk on the video series is like, what is an avalanche? Why do we care? And like the really like simple definition is it's snow moving down a slope. We got a couple types of avalanches. Let's
see. I'm going to change my speaker settings really quick because it seemed like it was really low. Seems good now. But kind of what we're focusing in on is like what avalanches are people worried about when you're out recreating. So we're primarily concerned with these slab avalanches, and that's what a lot of the discussion in the videos and again tonight will be focused on. But I think an important follow-up with that is like, this picture on the screen is like a decently large avalanche, but even small avalanches can pose pretty serious consequences to people. So the bottom line is like, if we're out recreating in the winter, we need to know about avalanches. And here's a couple like slides with some stats about what avalanche fatalities in the United States look like. So 2 years ago, we had the record-setting year, 37 avalanche fatalities in the United States. Last year in Montana, just bringing it into our zone, we had 4 avalanche fatalities. All of them were mechanized users, so snow bikes or snowmobiles. And this chart really like says it all. The majority of avalanche fatalities in the state of Montana are mechanized users. And so that's why we make sure to have outreach to those communities and run courses for snowmobilers and snow bikers. So I always think this is a really interesting graph. But bringing it back to what's important to us is that the reality is 90% of avalanche accidents are triggered by the victim or someone in their group. So that means like we have a lot of control over whether or not we're getting caught in avalanches. They're not just like a natural phenomena that we're affected by, like flooding or wildfires. Like we have a lot of say over whether or not we're affected by avalanches. So this avalanche picture on my screen, this was a snowmobile triggered avalanche last year. And a couple like stats about this incident. This avalanche only broke about 4 to 10 inches deep. I fast forwarded too quickly. And like a couple more pointers on this incident is like this slope down outside of West Yellowstone called Ski Hill. This is not a piece of terrain that I think most people would look at and be like terrified of, but it is steep enough to slide, and the steepest part of this starting zone was 43 degrees. So it's like absolutely avalanche terrain. It ranged into the upper 30s, which we'll talk about those slope angles a little bit more. But like looking at this picture, you're like, this isn't that big of an avalanche, but it's big enough to catch, carry, bury, or kill somebody. And that's what we're concerned with. So now back to like, what are these slab avalanches? And Alex's talk will get a lot more into the development of these slabs and weak layers and how weather can impact our avalanche conditions. But like to clarify some of the main points is like, to have avalanches, we need to have a steep enough slope, a slab over a weak layer. And then we need to have some kind of trigger, whether that's natural, like increased snow or wind loading, or melt or thawing, or a human or artificial trigger. So like in this picture, the split border on the slope. But yeah, my talk kind of hones in on terrain. So when we're talking about avalanche terrain, we're asking ourselves a couple questions. Is this terrain capable of producing an avalanche? And there's like, you know, we'll talk about the criteria right after this, but it is very knowable whether or not the terrain is capable of producing an avalanche. It's just a matter of having the right conditions. So then bringing it back to like how we make decisions and how we travel is like, what's going to happen? What are the consequences if there's an avalanche in this spot? And then, yeah, the last one is like the really important takeaway is like, what are we going to do about it? So that question of where do avalanches happen? We're talking slopes 30 to 45 degrees. This is where most slab avalanches are happening. Some other important characteristics of slopes would be like the direction it faces, the elevation, the slope shape, the size, and then that consequence piece. And I talked like at length about this in the video for terrain. And we'll talk about a couple of these pieces before I wrap up this recap. So when we're talking about those kind of prime time slope angles, like we're looking at this beautiful open slope. We have the most likely starting zone being steeper terrain, so that upper 30 degrees terrain. And then we need to think too about and broaden our definition of what terrain's capable of avalanching, or terrain is affected by avalanches, with like the terrain that's adjacent to it that's also steep, or the terrain that's under it that's less steep but could be impacted by an avalanche. So yeah, when we're thinking about avalanche terrain, we're also just thinking about like what the slopes underneath that avalanche terrain, you know, what kind of avalanche would get to those slopes. We've seen examples of that already this year where low angle terrain is subject to avalanches. And then following that up with, okay, so we know what type of terrain avalanches can happen in, but like where can we trigger these avalanches from? Like you can trigger them from on the slope with the right conditions. You could trigger them from adjacent to or underneath the slope, or with an avalanche adjacent to a slope sympathetically. So not to muddy the waters too much, but you can certainly be on a flat piece of terrain and be subject to an avalanche from above or adjacent to you, depending on the terrain and the nature of the snowpack. And Alex will probably talk a little bit more about what types of avalanches we're really concerned with, you know, being underneath or adjacent to slopes with. So then the kind of final piece of this puzzle, or one of the major pieces of the puzzle, is like, if there's an avalanche in this terrain, like what's going to happen to you? There's some things that amplify the consequences of avalanches, and we call these terrain traps. So thinking about, is the slope treed beneath the steep piece of terrain, or would the avalanche take you through trees, because that's just going to multiply the traumatic injury? Or are there sharp transitions or gullies or creeks where snow can bury it really deeply, and you can have deep, harder to deal with burials? Or are there cliffs or rocks beneath you, also amplifying traumatic injuries? Other thing to consider is like, are we in really big terrain that's connected to a lot of terrain? So these are all just things that we're considering, these terrain traps, or pieces of terrain that dish out worse consequences than your average piece of terrain. And I'll kind of end it with like just a couple plugs for good travel and just kind of pro advice is like it can get really complicated really quickly out there. Like there's a lot of different factors that lead to avalanches. And the reality is we want to bring it back to like the basics. Like what's really keeping us safe out there? And it's traveling one at a time in avalanche terrain, making sure we have eyes on people when we're in avalanche terrain, stopping and watching from less exposed areas, or traveling uphill if we're skiing, traveling uphill outside of avalanche terrain, or traveling through terrain outside of avalanche terrain when it's reasonable. So, and the other plug for that is too, like communicating can be really challenging, but good communication goes a long way with reducing your exposure. And that's the game that we play, is like, how do you make sure that, you know, when you find the right day to be in avalanche terrain, like that you're reducing your exposure as much as possible and you're setting yourself up for success. And part of that is just communicating with your group. All right, I'll open it up to questions, and I'll leave this little avalanche triangle as the last part of my recap, where I just touched on kind of intro to terminology and terrain, and like we really like walk away from this like thinking like terrain is really the piece of the puzzle that you can control. You can control where you're putting your body out there in the mountains, and so it's a really important thing to take away from taking an avalanche course. All right, I'm going to stop my screen share and see if we have any questions. All right, I'm going to answer Finn's question. Are point release slides indicative of avalanche danger? So point release slides or loose avalanches are indicative of like surface instability and like a lack of cohesion with the surface snow. So a point release or a loose avalanche would be differentiated from a slab avalanche, where slab is cohesive snow that's like moving down the slope, or breaks across the slope and is moving down in like cohesive pieces. Finn, did I hit on the major points of your question? It's just a different type of avalanche than slab avalanches. Point releases can definitely be dangerous to people. All right, any more questions with this topic? And if a question pops up for you later on, like, feel free to ask it, even if it's not like relevant to the specific recap you're on. All right, looks like we got a question from Brian. How do people commonly trigger an avalanche from below where it fractures? It's a good question. So like avalanche mechanics wise, what's going on there is I'm gonna do like a little hand demonstration. Like if you're below a slope, like when you collapse the slope, that collapse is being communicated up the slope, and that is how you could trigger an avalanche from below where it ultimately like breaks and has a crown. And you see this in conditions like particularly persistent slab conditions, where you have snowpack that's like very well connected weak layers or very widespread weak layers, and you'll end up seeing these remote trigger type avalanches. I hope that answered your question. All right, I think we'll move on to, I'll hand it over to Alex to talk about snowpack and weather, and then we'll get some questions with him. I'm going to stop my video and let Alex kind of take it from here.
All right, thanks, Shannon. Get my presentation up here. Okay. Got this. All right. So I'm going to be talking about the weather in Snowpack and really the slab avalanche formation. Shannon kind of touched on this. So yeah, we'll take it from there. And then we'll answer questions in Q&A after that. And then I'll pass it off to Ella. So. All right, let's go. So Shannon talked about this avalanche triangle and she talked about the terrain piece. And I'm going to be talking about weather and snowpack here. So it's these last two pieces. And like she said, we can really control terrain. We don't have to expose ourselves to avalanche terrain if we don't want to. And the other things that we can't necessarily control, but we can learn about is the snowpack and the weather. So I'm going to play this animation. And the way I like to think about this is, you know, a lot of us have jobs or we go to school and a bunch of little things happen to us every day. And it kind of changes the way we see things or how we present ourselves to the world around us. And the weather and the snowpack are going through those exact same changes, and we may not be completely aware of them, but they're having all those changes throughout the season. So it snows, maybe there's some melting, snows some more, and the wind blows and more snow, and it gets some layers on top. And then ultimately all that is existing under us while we're out in the woods. And part of being an avalanche terrain is trying to understand this process and being aware of what is going on with the weather. Because like Shannon said, if we're going to be out and recreating in the winter, we should really be aware of what avalanches are and how to avoid them and how to be informed about the weather and snow that's going on throughout the season. So one part of snowpack is you'll often hear us talking about having hard snow on top of soft snow. So this animation shows that really well. So this person's looking at the snow, pushing it, and then the fist goes right through the snow, and that's really sugary, weak, faceted snow. So that snow on top is hard, uniform, then weak again at the bottom. And the reason this concerns us is because when we have this hard snow on top of soft snow, it's when we start to get that recipe for a slab avalanche. So we talked about the recipe being you have a slab and you have a weak layer. So that slab was up top, the weak layer was the sugary snow. And then the slope below, or if you're on a slope steep enough to avalanche and you're on it and you trigger it, this is going to be something that is likely to slide. So there are a lot of things that contribute to instabilities and ways that that weak snow is produced. So with new snow, it's often comes from storm snow and wind blowing either during that storm or after the storm. So those are ways that we can have that slab on top of some form of weak layer. And this happens directly. And if you have a lot of storm snow, it can happen in hours and days, and then it's done. And after a little bit of time, sometimes those problems can cure themselves. But with persistent weak layers, the timing is a little different. They can last for weeks, months, sometimes the entire season. And these are those really weak, sugary forms of snow, sometimes that we see either at the very bottom of the snowpack. Occasionally they happen in the middle of the snowpack, and then surface hoar happens at the top, and then eventually it gets buried by new snow. So oftentimes the new snow is easy to track, but these persistent weak layers are the problems that kind of get us moving towards having a slab avalanche. So another way to drive home this point of having a good snowpack structure is upside down snow. It's a common way that people will talk about it. So you've got really weak snow at the bottom. Sometimes I like to think of like feathers or something, and then you have something that's like hard, like a big dictionary or encyclopedia on top, and that's going to be really unstable. It's not going to be able to support all that snow. Whereas you could have a right side up snowpack, and that would be like having feathers on top of a dictionary. So that's something that's good. So when we talk about this is often how like storm snow comes in, and we'll also have people talking about throughout the season as the snowpack develops that there's weak sugary snow at the bottom and there's a lot of wind-blown snow or storm slab snow on top. That's not good. So these persistent weak layers are depth hoar, and this is a cool CT image of what those snow grains actually look like, and you can see some of the striations there. So that's how you can see, but that depth hoar is, if you watch like GNFAC videos about the snowpack, you'll see they'll like grab the snow from the bottom of the snowpack and shake it through their Kinko leather gloves, and that's that depth hoar or faceted snow. And then we get things like near surface facets. So this happens throughout the season, and that's typically driven by the radiation from the sun, and then also getting the radiation from the earth makes those things happen, but it happens closer to the top of the snowpack. And then surface hoar is something that will form on top of the snowpack and then eventually get buried. So sometimes those will be those, you'll see them buried as like a thin gray line, but they're those really cool feathery crystals you see on top of the snow. And that snow today could be a problem 2 weeks from now if we were to get a snowstorm. So those are the common persistent weak layers that you'll hear forecasters talking about. So when you get these weak layers and then you have loading, the rate of that loading matters. So sometimes, again, if you reference the GNFAC videos, they'll talk about, well, we have this weak structure, but we haven't had any loading events. But the type of loading also matters. So new snow that happens quickly, it sometimes depends on the moisture content of the snow. And as that piles up, it could be enough to tip the scales and make that weak snow reactive, but sometimes it's not. And sometimes wind can happen even faster, or wind and storm snow together, which can form really thick cohesive slabs that are really heavy, and they can make those weak layers even more reactive, and you would start to see a lot more signs of avalanches. So when we talk about signs of avalanches, I like to think of this sometimes called red flags or bullseye information. So these are some of those bullseye pieces. We can think, okay, an avalanche might be really possible. Did we get a lot of storm snow, or has the wind been blowing a lot? And if you're just skiing out at the resort and you're wondering, like, are patrollers bombing things? Like, that's a really good sign of recent loading. And then we have recent avalanches. So that's like the best type of information. You're seeing avalanches while you're driving out to the trailhead, or you get a little further back just off the trail as you're traveling into the mountains and you see recent avalanches. This is like, okay, avalanches are possible, and the weather in Snowpack has created the conditions that steep slopes are capable of producing avalanches today. Another thing is shooting cracks. You might see them shooting out from your skis, from your snowmobile, from your snowboard. And that's another sign that you could possibly trigger an avalanche, because when your skis or snowmobile are pressing into the snow, it's communicating with the other pieces of the snow and shooting those cracks. So that's sometimes how those remote triggers can happen, where you aren't in avalanche terrain, but you cause one across the valley or wherever you are. So, and another one is collapsing, and sometimes people call this womping, and that's because you could be standing in a flat place and feel this almost like the floor drop from under you, and it makes a womping sound. And this is basically triggering an avalanche, but you weren't on a slope steep enough to cause an avalanche to happen. So you have this collapsing. And this is something that can happen just about like any flat if you do have these really cohesive or weak layers that are widespread and they're cohesive like that. So another one, and the last one, is rapid warming. So this is more likely to happen in the spring when you have warm weather and you're not seeing freezing temperatures. And that's because with these wet slab avalanches, what's actually happening is the warm weather is actively weakening the snow, as opposed to there being weak layers already existing in the snow. So just to go through these again, recent avalanches, if you see something like this, this is like, that is the best piece of information you can get, and you know that avalanches are possible. So the womping and shooting cracks and collapsing, like here, this slope wasn't steep enough to slide. It was just under that 30-degree mark that Shannon was talking about. And so see this crack going out, and obviously the slope collapsed, but it couldn't propagate. Or sorry, it did propagate, but it couldn't slide because it wasn't steep enough. Lots of snow. So when you're in situations like these, like this is recent loading, it's happening, and that is likely going to stress the snowpack. So it's a really good time to dial it back. Wind loading is another way that it really can ramp up the avalanche danger really quickly. And that's because these wind slabs are really cohesive, and when they get on top of a weak layer, they will stress the snowpack as well. And then rapid warming, like these are signs, snow's melting, you're seeing these roller balls, or you're actually seeing like this wet slab debris this is gonna be the result of this rapid warming. So when you're trying to make decisions about snowpack and weather, sometimes the information may not be as clear as you want it to be. Sometimes we don't get the recent avalanche, or it's snowing a lot. And so the way that we can get more data is actually digging down in the snowpack and being familiar with the layers that we're seeing. And other ways we can do that is go to the GNFAC's website and try and look at observations from other people, reading the forecast, trying to understand how the snowpack is evolving throughout the season, and then also seeing significant weather events like whether there's rapid warming, is there new snow coming, did snow come in the form of rain for a period of time, things like that are really important if you want to get out into the backcountry in the winter. Because we definitely don't want to roll the dice, because when we're rolling the dice, like our life is a part of that puzzle. And I'm not a person that wants to leave my life up to the roll of the dice. So that's all I've got for this, and I'll open up the Q&A and stop sharing my screen. All right, I'll answer this question from Sam. When a collapse happens, does that help the weak layer become more solid as the season goes on, or does it still remain unstable? I think that it's hard to say definitively that a collapse is going to make things more stable. But one thing that we'll look at is if a weak layer forms and then we have an active avalanche cycle, that sometimes that can wipe out that weak layer, but then you have a bunch of avalanches on those slopes, and that's going to be hard to determine necessarily like everything is stronger now because we had collapsing or avalanching happen. So it doesn't necessarily make it stronger. I think it just gives us better information about how the snowpack reacted to that weak layer. And if that doesn't seem to answer your question, you can type a follow-up or something. Okay, next question from Peter. What's considered warming conditions, any temp above freezing? So I think warming conditions, yeah, do we have multiple nights where the mountains aren't seeing freezing temperatures? So is it 35 degrees up at, the Bridger Ridge? And that's something where I'd be like, okay, it didn't get below 35 overnight, and I'm pretty concerned about that. So I would be worried about warming conditions then. But rapid warming, if the temperatures are under freezing, like we go from -40 Fahrenheit to 0 degrees, like it's not necessarily rapid warming in terms of something where I'm concerned about avalanche conditions changing. All right. So not seeing any more questions, Shannon, so I'll turn it back over to you.
Yeah, and I'll just talk for a couple minutes about the kind of human factor in decision making, and then I'll toss it over to Ella to take it in with rescue. I'm gonna pull back up my screen share. All right, I think I got it all pulled up here. Yeah, so what I'm going to talk about for a few minutes is just the human factor in decision making, and we've already kind of talked a fair bit about decision making as it pertains to terrain or travel choices, or even snowpack, like what Alex was just talking about with gathering more data or rolling the dice. That's kind of what I'll address even a little bit more. So we're back here with the avalanche triangle, and our fourth variable is us and how we interact with the terrain, the snowpack, and the weather. And that's kind of like what you all are like
in this avalanche course to work on, is like how do you go out and apply this knowledge to making decisions when you go out and want to have a good time. And the reality is, like, for those of us that ski and ride in the mountains, skiing and riding in avalanche terrain is fun. Like, we want to be in the type of terrain that can do us a lot, that can harm us and can do damage to us. So looking at this picture of Henderson out in Cook, we see someone high marking a slope and a group kind of all gathered on a bench beneath this piece of steep terrain. And the photo I'm about to show you after this would kind of make you pause about the decision making of this group. But I'm not really here to like roast these people for high marking a slope. I'm more just here like trying to provoke some questions about like, how do we set ourselves up to make good choices for ourselves and our families and our groups in the mountains. So here's Henderson Mountain one day, where high marking this slope was a good decision or didn't lead to a bad outcome. And here's another day on same piece of terrain, very different story. And you can see that bench. I'll pull up my clicker. You can see that bench here in the middle of the slope. That's where all those people were grouped up. And if there had been, you know, a whole group of people right there on this day, it wouldn't have been a happy story for anyone involved in this incident. So just thinking back to like that terrain lecture or the terrain recap of like understanding that some terrain is capable of avalanching and like capable of producing just really bad consequences, and that we can make choices that help us out and help us not be as exposed to those bad consequences. So yeah, here's just another angle on that same avalanche incident, and this is from that bench. So if you were posted up on that bench this day, you would have been buried under a lot of avalanche debris. This is quite a large avalanche shown. The crown here must be, you know, easily 2 or 3 meters deep, 10 feet deep, maybe at the deepest. So pretty darn large avalanche. But yeah, when we look back at avalanche accidents, like I said, we're not really looking to cast judgment, but the reality is we can learn from our own mistakes and other people's mistakes. And what we're seeing time and again is most avalanches are happening because we underestimate either the avalanche hazard or what the terrain is capable of producing, or we overestimate our own ability to deal with that terrain or that avalanche hazard. So how can we set ourselves up to provide a little bit of buffer or a little bit of protection between, you know, our own ability to mismanage or misjudge hazard, or our own ability to underestimate the hazard in terrain? So that's what I'm going to talk about. But yeah, the reality is like our decisions lead to avalanche accidents. So we got to take a little bit of ownership over the choices we make for ourselves and our groups. So oftentimes it's a combo of good decisions and good luck can help us avoid these accidents. But a lot of times when we look at accidents, we see that, you know, either there were poor decisions made or they just got really unlucky with some of the choices that they made. Like they made good calls and had good terrain and group management, and they just got really unlucky, and we end up seeing all kinds of accidents. But I'll talk really quickly about kind of what the human factor even means, ways that we make decisions. You know, I don't need to talk to you all about like the way that people make decisions in their day-to-day life, like isn't always based on you know, like rational thought, or like you're not necessarily like pausing to weigh certain decisions. But I think I would encourage people to be a little bit more critical or calculated in avalanche country, because the consequences of your decisions are just a little bit higher. So some of these human factors that lead to ways we make decisions in our day-to-day life, they're no different when we're all of a sudden out in a snowy environment. I'm just going to kind of go through this list. But yeah, these are the type of things that can really do damage to us out there. Particularly thinking about like being objective oriented, or your perception of yourself and what type of terrain and what type of skiing or riding you do can really hinder your ability to make good decisions out there and to make decisions that are reflective of what you're actually seeing and what reality is actually telling you. So I'm going to spend a lot more time thinking about like, how do we make good decisions than like dwelling on some of these factors that are like, this is how people make bad decisions. And I think we all can identify some of these factors that lead to us making decisions in our day-to-day lives that are like, wow, I really wish I didn't, you know, look at social media and think, oh, I should be out doing this, or oh, I should have skied that, or you know, like whatever it is, I should buy this. So I'm sure that's relatable to most people. But there was this acronym that was created, and I'm not going to spend too much time talking about it. You can ask, and during your field day, you can ask instructors about this. But this is more like shortcuts to decision making. Like instead of having proof about what's going on around you and having like a critical discussion about whether or not you should be putting yourself and your group in certain terrain, you're using these shortcuts. I was there yesterday. I've been there every week for the last 6 weeks. That's like your familiarity. Acceptance is like, wow, everyone else who's got more experience than me is fine putting their body on that slope, but I don't feel comfortable with it, and it's hard to speak up. The commitment, you're taking a trip that you've spent, thousands of dollars already sunk into. You took 10 days off work, like you want to go ski or ride this. That's really hard to turn away from. Same with like relying on people who have more experience than you, or what you perceive as expert judgment. And then same with like kind of this social proof or facilitation, like you watch what other people are doing and you assume that it must be safe because they haven't experienced bad consequences. But as Alex was talking about, especially with these like persistent slab avalanches, sometimes you can put lots of bodies on a slope before you're going to see an avalanche. So like these kind of shortcuts don't do us any favors in that environment. This picture is really just like a hammer home of the statement I just made. Like this piece of terrain outside of Bridger Bowl sees a lot of tracks, and it is very consequential avalanche terrain. And I think that people would be well served being a little bit more like reflective or contemplative about like what the consequence of making a bad decision up here could really look like. But I think it's very easy to watch, tens or hundreds of other people make a decision and for you to assume it's fine than to do your homework. But I would encourage people, like, if you're gonna play in terrain like this, you should really be doing your homework. And that's kind of what I'm about to talk about. Like, what does that even mean? So we need to make objective assessments of the avalanche danger and adjust our travel plan and terrain use accordingly. So back to that bullseye data. This is stuff that we are taking more into consideration than those decision-making shortcuts. Are you seeing avalanches out there? Are we seeing loading? Is there rapid thaw? Are there known weak layers that the forecast is concerned about? These are more important pieces of data than like these other bits that I've already talked about. And this just kind of keep asking these questions, like keeps you and your group a little bit more honest about what you're actually seeing out there and translating that into terrain decisions. So another tool we can really lean on is this avalanche forecast. So you don't have to be a forecaster for yourself. Like we have an awesome avalanche forecast. I'm guessing that's how most of you all arrived at this Q&A, this course tonight, is through the GNFAC's website. And so what are we getting out of this forecast? It's telling us, what the avalanche problems are, where you're going to find them, how bad is it, how big are the avalanches, what kind of observations have we been seeing, what can you expect based on the weather forecast. That's kind of just like the really brief summary, but you can get so much out of this page, this forecast page, and the website at large. So the question is always like translating your knowledge that you've got from this course or from the forecast. Like, now what? Like, how do you go about making decisions? For different types of avalanches, you're gonna have to have different ways of using terrain or different solutions. So just being aware of that. Hazard ratings are way more than just a color. They have terrain advice. They give you a lot of indication about the nature of those avalanche problems. And yeah, like looking at the forecast, like what's appropriate terrain to be in based on the existing conditions. And that's like not a question that, as an educator or avalanche professional that I can answer for other people. There's like recommended terrain based on the existing conditions and the hazard rating. But you get to go out and make those decisions for yourself. And then another important thing is like, think about what your criteria are for being like, oh, I'm going to pull the plug on being an avalanche terrain today. Like if you were thinking that was on the table when you were talking to your friends the night before or the week before or the morning of, depending on how far out you're planning, like considering what you would need to see out there to change your plan and like actually being willing to stick to it. And then like the last bit of this is like, you may know some things, but what don't you know about what's going on out there? And how are you going to go about finding that information, whether that's digging pits or traveling through a bunch of terrain or deciding that you're like, maybe I don't know what's going on with the snowpack and that freaks me out and I want to stay away from avalanche terrain today. Like those are all like appropriate solutions. Like you've had drastic change and maybe you want to avoid certain slopes. These are all kind of like actionable solutions. And that's what decision making is all about, is like, how do we take information and like go do something with it? But yeah, like back to, and this is actually the same picture that was in my slide deck, but like after you've gathered the facts or made or updated your plan, like make sure you're following these good terrain practices to like stack the odds in your favor should you be wrong. You know, humans are fallible and you may not be right all the time. So make sure you're setting yourself up for the best possible outcome if you're not correct. And this picture is just an avalanche incident that happened a couple years ago in the tobacco root range. And looking at it, I used to work in the tobacco roots, have skied adjacent to this slope many times. And this is a piece of terrain that I genuinely don't think the people involved in this incident were aware of how bad the consequence would be should they be wrong. And they were very wrong about what the stability was on this slope. And they seemed to be, you know, looking at the accident review, like unaware of how bad the consequence would be. So it's just kind of a sobering reminder that like, it's easy to make bad decisions and it's even easier to get unlucky. So when we think about the big picture, like it really just takes time to practice making decisions. And some of the decisions you make aren't always going to be good. But you want to make sure that you're like slowly increasing the consequence of your decision making. Like you're not just going straight out onto that big slope like that picture I just showed. You know, you're tiptoeing your way into terrain, not just going out into consequential big terrain, especially as you're learning. So yeah, we'll leave on this, like, recognize when the decisions, it's hard to recognize when the decisions you make are good or bad. But if you practice discussing with your group afterwards how they felt, how everyone felt about the decisions you made that day, and like, did you stick to your plan? Were the conditions what you expected? Would you do it again if you had the same day, same conditions the next day? You know, being willing to be critical of yourself and your decision making will go a really long way in getting better at making decisions, because you can't just, no one starts their backcountry career off just like making the right call every time. Even professionals don't make the right call every time. So that's kind of what I'll leave with and toss it to any questions. Let's see. All right. Let's see, let me pop up the Q&A. Let's see, oh gosh, my screen just did something crazy. Hold on. There we go, am I out of my screen share?
Yep.
Awesome, my screen it like totally flashed back into my screen share after I undid it. The question, any resources to help find backcountry partners? That's a hard question. I think getting out there and going and taking an avalanche course is a great like step into finding more partners, because you're going to find like-minded people, or going to like avalanche lectures, or just going out and like meeting new people is hard. And the backcountry partners, you've got like a little bit more selective criteria than like people you are just going to the bar with, or like going bowling with, because there are people who, as Ella is about to talk about, might end up saving your life one day. And there are people who you want to be able to make decisions with or learn with, or help you out when you're in a bad spot. So I don't know if I can actually answer that question. I can't think of any resources other than like online forums or taking classes. Like that would be the way to start meeting new backcountry partners. All right, I think I'll hand it over to Ella to take us home with rescue.
Okay. All right, Shannon, can you see the screen?
Yep, looks good.
Okay, awesome. Like Shannon said, I'm going to talk about the avalanche rescue part of this. And if you have any questions during it, throw them in the Q&A and I'll try and answer throughout, and then also review the Q&A when we're done here. So like Shannon mentioned, you can do all the right things and sometimes you just have bad luck. So this is for everybody, whether you make bad decisions or you make good decisions, you might end up in this situation. So the most important things when traveling in avalanche terrain is you need to carry all the gear, and each member of your group needs to be carrying every piece of equipment. So the 3 essential items are your transceiver, your shovel, and your probe. So your transceiver will get you close to your partner, your probe will locate your partner, and your shovel will get you to your partner. So if you're missing one of those 3 elements, you're not going to have a positive outcome. And you need to practice with your gear and be proficient with it. So it doesn't matter if what I like is different than what you like, as long as I'm proficient with what I have and you're proficient with what you have, it's fine. Shovels, plastic is not okay, so you want a metal shovel. And then before and after an avalanche incident, you want to be traveling one at a time. So you're only exposing one person to a hazard at a time. So watch your partners from a safe spot. So it's kind of a small image there, but there's one person descending a slope and 3 people at the bottom. If that last person triggers an avalanche, those 3 people in the bottom are in the run out zone within the path still. So you're potentially burying everyone in your group, and who's going to help you then? No one. So if someone is caught in your group, you need to do your best to stay calm, take a deep breath. There's nothing you can't make worse, so don't be that person. And have a plan and begin your rescue. So having a plan is, you should have a contingency plan when skiing or riding a slope. And part of that contingency plan is what am I going to do if this avalanches? What am I going to do if an avalanche is on the first person who skis or rides that slope? Second, third, where you are, where your partners are, and everything like that. And then you're going to begin your rescue. If you're caught in an avalanche, if you're that person, again, do your best to stay calm. Try and get to the sides of that avalanche and swim. You're just trying to elevate yourself higher up in the debris so you're not buried fully or not buried as much, trying to make yourself larger. So if your partner is caught, here's kind of the layout of an avalanche search. So first things first, don't enter the terrain unless it's safe. Again, there's nothing you can't make worse. So you don't want to be burying 2 people. You just want to minimize that. So proceed with caution. Go to the top of the debris or the last seen point. So this little demonstration here is set up for if you were at the high point of the slope above the avalanche and the compared to coming up from the bottom. But the principle is the same. So top of the debris or last seen point. So a signal search is when your transceiver is on and you're just waiting to pick up that first signal. And then that'll probably be, most beacons are between 60 and 70 meters. And then your course search is once you get that signal, then you're narrowing in, decreasing those numbers. And you can see the zigzags there. So the zigzags are your signal search. You're looking for a signal, traversing the debris there. And then the little red dots, that's your course search. So once you have your signal, you're just following your numbers down. And your find search is when you're within 3 meters or less. And your pinpoint is your probing. And then, of course, the hard part is the digging. So probing, it's where I've seen most people get frustrated very easily. You know, you won't always hit something on the first probe strike, and that's okay. You need to stay calm and be methodical. So you're going to probe at the point in which you have the lowest reading on your transceiver. And then you're going to probe in concentric circles or a spiral. And so each probe, as you're methodically doing this, each probe hole is going to be about 10 inches apart. So, you know, you're going to be flustered, and that's fine. The best way to remember the distance is look down at your foot, you know, in ski boots or snowmobile boots or snowboard boots, your foot's around 10 inches. So just aim for that distance apart from every probe that you do, and just stay calm and be methodical. When you're probing, you should probe perpendicular to the slope. So if I have a super steep slope, I'm going to be probing at a pretty aggressive angle there to try and make that perpendicular. The lower down the slope, the nicer angle that probe is going in at. So you're not probing plumb, which is gravity. You're probing perpendicular to the slope. And then once you have hit or, you know, probe striked your partner, then you're going to leave that probe in place. And that's just to indicate to you where you've actually hit them. So I have a question here. How do you know if you make contact with the victim? And I assume that's with the probe strike. So you guys will practice this in the field sessions, but you'll bury a backpack and you'll feel the spongy kind of springiness of hitting a backpack or jacket or something like that compared to probing the ground or a tree. So it feels different. And then you'll also have a different height reading. So if I probe and I'm hitting the ground and it's saying 3 meters, and then I probe something and I'm like, oh, that feels a little spongy. And oh, it's only 1.5 meters. Well, that's most likely your probe strike of your partner. All right. So the digging, it's the most time consuming and hardest part for sure. Once you have successfully probed your partner, you need to then move downhill, down slope of them about 1.5 times the probe depth. So if I probe down and my probe depth is 1 meter, I'm going to go roughly 1.5 meters downhill and start digging. You know, don't waste your time to look exactly what your depth is. Point is, take a couple steps back and start shoveling in from there, because you're trying to make a nice wide ramp to extricate a human-sized object out of the ground. So you don't need a little rabbit hole that does you no good. You need to make a big platform, because you are then going to have a patient. You can see our little animated guy there making his nice wide ramp down to his partner. And another benefit of that wide ramp is you don't know what part of the body your probe hit. So it might be a foot, might be the chest, might be their head. You know, you need to get that airway as soon as possible. So you need to make that nice wide ramp. No bunny or rabbit holes right down at the probe. That does you no good. So that's just a really quick overview of avalanche rescue. You guys will do this in your field sessions as well. And if you guys have any other questions, go ahead and ask them. And I'm going to stop sharing here.
Thanks, Ella.
Yeah.
It looks like we have a raised hand. I'm gonna let Sam talk. Go for it, Sam.
When do you notify, if you can, emergency personnel? Like how quickly should that be on the agenda?
Yeah, so statistically speaking, you have about 15 minutes to have like a 90% chance of survival with a full burial. So those first 20 minutes are crucially important, that you're dialed in on what you can do as a rescuer. That being said, you're completely reliant on your partners to rescue you. Organized rescue is great, but it's not there for the initial survival of a patient. So I would personally, do my beacon search, probe strike, shovel, get them extricated, and then I'd be calling for additional resources. If you have multiple people, you can delegate, and one person is doing that beacon search and one person's calling 911. But really, your partner's best chance of survival is you. Let's see. What is the best way to search with beacons if you have more than one person buried and more than one person is searching? So depends a little bit on how big the path is. There are different techniques for like super large paths if you're dividing the path in half or quarters or whatever. But you need to know your beacon's range roughly, it's 60 to 70 meters. The way we train is, if you're doing multiple rescuers, you're both just, you divide the path if necessary, and you're searching until you get that beacon signal. And then if you both happen to go to the same one, great. If you have multiple buried victims, then you when you start getting sucked in next to your other searching partner, you're going to continue a normal search trying to get an additional signal. So lots of different ways and techniques to do multiple searchers, multiple buried victims. And you guys won't get too in depth on that, but turns out shoveling is way easier with more than one person too. So more people, the better. What kind of scene danger would make you not initiate a rescue other than a recent avalanche? So if you're above and you have to descend a slope and there's a significant amount of snow between your location and the crown of that avalanche, that's called hang fire. And so you have the potential of kicking off a second avalanche in that hang fire by descending it. So that would be something to consider. What's your safest route in? It might be a longer route in to avoid that hang fire. And then same thing coming up from the bottom. If you feel like there's too big of a hazard with overhanging, the still hang fire above, everybody has their own risk tolerance, but it's something definitely you should consider. You take an EMT class or anything like that, and the first thing you're supposed to recite is scene safety. So there's nothing you can't make worse. Keep that in mind.
Ella, looks like you got a question in the chat box. I can just read it because I'm looking at it. If caught in an avalanche, is it best to dump gear while sliding? I imagine having a snowboard attached to your feet could cause you to get buried more easily, but 1 foot in a binding could easily cause a broken ankle. Yeah,
it's going to be too fast to do anything with your equipment if you have to release it yourself. Yes, equipment does present problems in contorting your body weird if you're buried and stuff like that. But honestly, I've never heard of anyone say that they had time to address any gear. People don't always get their airbags pulled, and that's relatively simple for as far as managing your equipment. So I would focus my energy on getting to the sides of the avalanche more than what I have on as equipment. And then there's a pit question. I don't know if you want that, Shannon, or.
Alex, are you still on the call? Do you want to jump back in if you want to take this one?
Yeah, I can do this. All right. Reading this. If you must dig a pit in avalanche terrain, what are some guidelines? I think actually a great thing that's come out of a lot of research is we don't actually need to dig a pit in avalanche terrain to get information about weak layers. So when I was talking about collapsing and womphing, that's when you can kind of get one of these weak layers to react while you're not in avalanche terrain. So digging a pit is kind of the same thing. So I can go dig in a flat location and still be able to do a couple of tests that you'll learn on your field day and see whether those weak layers are reactive to loading. So I think the biggest thing is you have to dig in a safe spot. And if you're worried about avalanche danger, digging in avalanche terrain is probably not ideal.
Any other questions? We can stay on for a few more minutes just if anything pops up.
So there's one more question. If there is an avalanche coming towards you and you can't get to the side, would moving behind a large tree or holding onto it be helpful? Yeah, you do the best you can. Being behind a tree, there's going to be a lot of momentum going past the tree, but yes, holding onto it gives you a slightly better chance. I don't know how good your grip is, but anything you can do to make your odds better. I know there's a bunch of ski guides that are way into holding trees, so why not?
And yeah, just while people are still on, just fill in some time here. Just reiterating the points in this chat box. Should you or any of your friends have missed out on some of the call tonight, a recording of it is going to end up on that YouTube playlist with the rest of the fundamentals videos. And as far as course logistics info goes, like look for those emails from friends of GNFAC or for Eventbrite. And if you have any questions about course logistics, just ask. Better to know before you show up, especially showing up like to Buck Ridge where there's no cell phone service without the right piece of gear that you need. So definitely ask if you have any questions. And like the goal with doing these Q&As is like we hopefully you watch the videos, you got some of your questions answered, you got pretty primed, and now you're going to get to go to a field-based course and like get hands-on with a lot of these topics we talked about, like seeing avalanche terrain, looking at layered snowpack, doing rescue for yourself and your partners. So yeah, looks like we got another question in this chat box and maybe the Q&A. Let's see, for the question in the chat box, it says, when looking at grain structure, is larger typically worse? Are there other things to look for? And I can answer that, or Alex, if you want to go for it.
Yeah, I can answer that one. I think that, yeah, I mean, if you get down to the grain level, we'll find that faceted snow they're larger grains, but actually what the real problem is, it's not necessarily whether it's large or small, it's the ability of those grain types to bond to one another and start to become stronger. So we have less weak layers lower in the snowpack. So I think that those are the things we're looking for. It's not necessarily whether it's a large grain or a small grain.
And I'm answering another question in the Q&A, but maybe if there's another one that popped up, if you want to handle that one.
Yeah. So I think looking at this question, we have small or no trees equals past avalanche activity. Large trees equal a terrain trap. Where do I want to ski? I think that it's really easy to get like caught up in all these little things about avalanche terrain and like, are there small trees, so there must be frequent avalanches, or there are large trees that I might get pushed into with a big bank of old growth trees. Maybe that can be a terrain trap, is where I've seen trees turn into terrain trap. So I don't think it's like I'll never ski one of these slopes because of those conditions. It's going back to the things we talked about tonight. Like, is this terrain capable of producing an avalanche, and what are the weather and snowpack telling me? And am I with the right people, and do I have the skills to rescue if something bad happens? So it's more about learning to make those small decisions while you're out there, instead of just going like, I'm not skiing any slopes with small or no trees because an avalanche has happened here recently. That doesn't mean you can never ski it. But I think that's the way I approach that, instead of limiting myself to all types of terrain.
Cool. I think we'll start wrapping it up here. So yeah, any kind of last call, any questions, any lingering questions? Otherwise, you're going to have to save them for your field instructors. They're looking forward to your questions. Like I said, please send those like logistics type questions to the friendsofgnfac@gmail.com. That's going to be the like fastest way you can get those questions answered. So just big plug for that. Like, if you have any questions about the course, send it that way. So the last question that just popped up in the Q&A is suggestions for a good inexpensive beacon. And like Ella said, the best beacon is the one that you know how to use. Most beacons every beacon that's on the market at this point, like, and I'm talking like new market, like I do not recommend people buy used avalanche rescue gear. All these beacons on the market now are modern digital 3 antenna beacons, and you're not necessarily going to go wrong. If you need recommendations for like local retailers, like go ahead and email that friendsofgnfac@gmail.com, or yeah, if you have questions about local rentals for equipment. And this other question is beacon search areas. So we didn't actually bring it up, but there is a beacon park at Story Mill right now. And there, actually, Ella may know this more than I do. Ella, is there a beacon park up at Bridger right now?
Yep, there is. So it's not the normal BCA one that we can have like 8 beacons on. So there we have 2 beacons buried, and we change the locations occasionally, but it's located in the South Bowl. So if you ride the Piers Knob lift, the South Bowl is to the lift rider's right. It's that big basin there. It's all marked out and everything. So you'll see that in the South Bowl.
Cool, thanks. I know that there's a beacon park usually set up below Challenger Lift up at Big Sky as well. The Friends of GNFAC helped set up a park in Cook City at the softball field, and there's one out by the old airport in West Yellowstone too. So lots of awesome resources for getting good practice. And like the field-based course, like you're going to get some hands-on practice with technique, and then it's up to you to keep practicing with all these skills. So I think that's it for questions. Thanks everyone for tuning in, and we look forward to seeing you at the field days. And like I said, reach out if you have questions for how to show up the most prepared for your field day, or refer to those kind of long logistics emails that you end up getting. So awesome. Thanks everyone for coming out, and hope you have a safe rest of your season. And make sure to think, though, the final pitch I'd say is like, enjoy your field course. And if you get out there and see any avalanches or see anything interesting in your snow pits or observations, send it